So now we're back learning GDScript from zero, and this is an open source project by GDQuest.com. We're going to continue from where we left off over here at functions that return a value. All right. So until now, we learned that functions are sequences of instructions we give a name and we can call anytime. On top of that, functions can make calculations and return new values. True. But let's look at some examples to see why it's useful, right? We've got built-in functions that return a value. Many functions built into GDScript make calculations and return a new value. Okay. For example, the round function takes a decimal number as an argument and gives us back a new number rounded to the nearest digit, right? So if we say var number equals round 3.4, it's going to round down to 3. And then when we print number, this is going to give us 3. When we run it, boom, right like that, we've got the 3. All right. So imagine we have a game where we track a player's health as a percentage, a decimal number going from 0 to 100.0, 0.0 to 100.0. All right. When displaying the health on the interface, we don't want to show the decimal part. In that case, we may want to use the round function like so. So we've got var rounded health equals round, and then health. This health right here. Huh? And then we say set text rounded health. I guess this is what the set text does. Let's say, I guess. And then this is going to be round, I guess this health right here. And we can see it rounds the 0.3s and then the 0.1. Let's try to get like over. What's the deal here? What's the deal with this? We can't get over 5. There we go. All right. And so this one rounds it up to 36. All right, cool. Anyway, you saw it. You saw it live. I record this stuff live. All right. Notice how we assign the result of the function call to a variable. What? Also, this little turtle is going to kill me. All right. Notice how we assign the result of the function call to a variable. Excuse me? Excuse me? What are you talking about? Is something going on off the edge of this screen? So, you know what I'm saying? What? Is this what happened? Is this? Oh, so it's this. Okay. Okay, let's go back. Because this is the same thing as this. It's set rounded health like that. All right. So notice how we assign the result of the function call to a variable. Oh yeah, it's a function called round. Okay, because the round function returns a new value, we need to either store the result or use the value immediately. All right. Above, we assigned it to a variable. We could also do the following. So this is going to be using it immediately. The round health. Is that what we're talking about? Oh yeah, we're talking about return statements. So yeah, this round. We're going to be using this returned round immediately inside of this set text. That's what they're trying to say, I think. All right, so we can assign the return value to a function call if we plan on using it more than once. A cooler example, lerp. Honestly, that's not a cool word, but we'll see. The lerp function, short for linear interpolation. No, linear interpolate. Okay. Calculates and returns a weighted average between two values. Okay. It takes 3 arguments, 2 values to average, and a value between 0 and 1 to skew the results. Okay. In game programming, it's used to animate things moving towards a target with a single line of code. Is that how it slows down? Is that what's going on here? Because it looks like it's like exponentially slowing down. Anyway, position lerp. What? What? Oh, weighted average. What? Pardon me. Weighted average. What? What? Okay, position. What? Get local mouse position. What? What is all this? What is position? Position equals lerp position. What? Okay, so it's doing it. What? Hold on. Excuse me? What? Excuse me? Okay. So this is taking whatever position was right before it. Like, look at this. Okay, look. This is what? 60 frames per second? Whatever. So every single time every little instance it moves, it's doing this. It's taking the position it was before, and it's throwing it inside of this lerp. And get local mouse position wherever the cursor is, that's what this is. And then we're also going to have 2 delta, and delta is going to be, you know, whatever 1 divided by 60 is times 2. So 2 divided by 60. So 1/30th of a second, which is still very small, right? That's crazy. That's crazy. We need to remember this lerp. We have to remember this. We have to put it in our minds that it was lerp. Or at least remember where to get it at. Because look, it's what? It's a weighted average. That's the thing I don't understand. What does weighted average mean? Because this is 1/30th instead of like 16/30ths. It's going to skew more towards this. What does weighted average mean? You know what I'm saying? Anyway, we'll learn about that crap later. It's good to think about this stuff and not get the answer. And then once they say blah, 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 later we'll say, oh, yeah. We gave that a lot of thought. You know what I'm saying? Like we did earlier with when we came over here and we were doing magnitude, right? Not magnitude, vectors, the magnitude thing about vectors, right? We knew what was going on when we came into this because we had that whole episode on it, right? Even though it was the totally wrong direction. Still, let's go. Every frame, the code calculates a position somewhere between the turtle and the mouse. Yes. The lerp function takes care, and the mouse cursor, the lerp function takes care of everything. It's not telling us what it's doing. It's really, I really hate that. I really hate that. Like, it's 2024 and this person totally didn't tell us what was going on at all. It's so annoying. Whatever. It's not the most robust approach for smooth movement, as we'll learn in the future, but it's a helpful function nonetheless. They didn't tell us at all what's going on here. Because all we need to know is what a weighted average is, honestly. That's the only thing that doesn't make sense. This is, okay, so this is going to be 1/30th, right? Because let's say and we're just assuming here, let's say we've got 60 frames per second, which I mean, of course not, because this is literally the raw frames per second that your computer has. So mine's like, I got like a few, frames per second. I don't know how to check that. And we're not going to check that right now, but regardless. So I don't know. I just wish I knew what that meant. Anyway, so let's go to the next part. Writing a function that returns a value, right? So we can make our functions return values. To make a function return a value, we use the return keyword followed by the value in question. True. In previous lessons, we had characters walking on grids. Yes, we did. And for those practices, we were working directly with cell coordinates. We were doing that. I remember that now. Well, cell coordinates don't correspond to positions on the screen, believe it or not. To find the center of any cell on the screen, we need to convert the cell's coordinates to a position on the screen in pixels. All right. So we see right here, this one's 60 by 60. So 60 by 60. And we're starting the thing here, I guess. And then this is going to start at 180. So this whole thing is 180 big. Okay. I guess. No. 180 big, 60, 60. 120 big. This thing's just 120 big. Okay, so it's... Yeah. Is that what it's up? Okay, yeah. So it's 120 by 120. Okay, cool. Anyway, let's keep going. So... to do so, we use a function, and the function does two things. What? What are we saying? What are we doing right now? Okay, so we got this cell world position. So it starts at 60, 60. Okay, this is 60, and this is 60 this way and 60 this way. Even though that looks like freaking like 500, right? But that's I don't get it. I don't get how that's 60. Is it just? Is it just a fake number? Because this is definitely not half of this. Like, if this is 120, this would be this. Yeah, okay. So they have to be. They have to be just giving an example world position. I guess that's what's going on here. I guess that these are just example numbers. Let me click this. I guess this is just an example 60-60. Actually, it's not 60-60 at all. I guess that's what's going on. That's got to be what it is. That's why I'm confused. Maybe you weren't and you wanted to fast forward. Anyway, let's go. To do so, we use a function. What are we doing? Well, cell coordinates don't correspond to positions on the screen. To find the center of any cell on the screen, we need to convert the cell's coordinates to a position. Oh, it's the center of it. So this is, I mean, it's still not starting at any 0, but I guess we're going to say this is 0 here, and the center is 60, 60. Okay, I see. And then the center of this one is 60, 180, because we didn't move any this way, but we went down 120. Haha. Okay, let's go. So first, the function does two things. First, it multiplies the cell coordinates. Hold on, what? Anyway, okay. So to find the center of this, we do that. So to do so, we use a function to find the center. And the function does two things. First, it multiplies the cell coordinates by the cell size. Cell coordinates by the cell size. Cell coordinates like what? Like 0, 1. Oh, 0, 0. Okay. Cell coordinates by the cell size. So 0, 0 by the cell size, which is 120 by 120. Which gives us the position of the cell's top left corner on the screen in pixels. What? I guess it would, because it would be 0, 0. Okay, then we add half of the cell size to get the corner of the cell. So we divide the cell size, which is 120 by 2, and then add that to each one of these. So it gets 60 here and 60 here. So 60, 60. Okay, and this one's going to be... What? What is this? What's going on here? It's 120 times 1. So that's 120 plus half of 120 plus 60. So 180 to the minute. So the 120 here and then 180 here. And then it's still 0. So it's still plus half of 120, so 60. Okay, I see. Okay. Then we add half of the cell size to get the center of the cell. Yes, okay, so we did that. The function returns the result, allowing us to store it in a variable. I don't know. I mean, are you able to get this like without like looking at it and saying, what? Leave a comment in the comments. The function returns the result allowing us to store it in a variable. Of course. We have var cell size, vector 120 and 120. Vector 2, 120, 120. Func, convert to world coordinates. Cell, which would be this. No. Huh? What? Anyway, convert to world coordinates cell times cell size. Okay, so 120 times 120, yeah. Plus, no, cell size, what? So cell would be one of these. So we would, okay, so the argument for this would be like vector 2, 1, 1 or something like that. All right. Okay, and then it would return us a vector 2. Is that what would happen? Let's see. Run it. Yeah. Okay. So it would give us a vector 2. Okay. What's this crap? The return keyword returns the value to the code calling the function. We'll receive the result when we call the function. Var cell size equals vector 2, 120, 120. Okay. Func run. Var world position convert to world coordinates. That's this thing. And then we're going to call vector 1, 1, vector 2, 1, 1. Okay, so it's this one right here. And then we'll print world position. That's what this thing is, this function call. And it gives us that. It gives us this same thing as 1, 1. 180. 180. There it is. 180, 180. All right. Let's keep going. Some functions return values and some do not. During practices, we can learn which functions return a value using a documentation panel. It will display if the practice requires using specific functions or what? Some functions return values and some don't. Yes, okay. During practices, we can learn which functions return a value using the documentation panel. Isn't that what we've been doing? It will display if the practice requires using specific functions or variables. I think that's what we've been doing. There are functions that start with the term void do not return a value. Okay, so that's why some of them have been saying void. They don't return a value. Any other term means the function does return a value. Okay. We'll learn more about what other terms mean in a couple of lessons when we explore value types. For now, let's practice returning values from functions. Okay. So this first one, or the only one we're doing, is converting coordinates from the grid to the screen. Okay, so we lost the function to convert grid coordinates, but we desperately need it for our game. We're going to make the turtle move again by coding it. All right, so we're going to pretty much do the same thing as like this thing. So let's remember it one more time. Cell times cell size plus cell size divided by 2. I know because I had to do this. I do rehearsals in this. Anyway, let's go. I did it in rehearsal and I forgot it. So define a function that converts a position on a grid to the screen. The function takes a vector 2 cell coordinate as an argument. It should return the corresponding vector 2 screen coordinates at the center of the cell. Okay. So we're just going to return, and then we're going to say, what was it? Cell divided by cell size? Cell times cell size? Cell times... Ooh, come on now. Times cell size plus something divided by 50 divided by 2. Cell divided by 2? No. Cell size divided by 2. That's what it's got to be. Right? What the hell was that? Let's run it. Looks good. All right. I don't know if you can hear my phone going wild. I think it's one of those alerts. I think it's an Amber Alert though. Anyway, so we completed the practice. Let's continue. I got to go look at that. Continue. All right. So now we're on to appending and popping values from arrays and appending and popping values from arrays. And we'll see you next time.